Hello students, this is lesson U4A02b. By the end of the lesson, you should be able to say, I can use properties of sides and diagonals to identify a parallelogram on a coordinate plane. So, in the previous lesson, we went over the 5 different properties that makes a quadrilateral a parallelogram. Pause the videos to see if you can recite what those 5 properties were. So hopefully everyone here got a chance to think and reflect on what those properties were. Let's take a look at it again, but this time we're going to examine it in the context of on a coordinate plane. So if you recall, there were 5 properties again, okay? The first of which was opposite sides are parallel, second is opposite sides are congruent, third is diagonals bisect each other, fourth is one pair of opposite sides are parallel and congruent, and the 5th property was opposite angles are congruent. No particular order at all, okay? I'm just listing them out. So this is true, okay, for if we were to work with parallelograms on a regular plane, if we were to solve algebraic problems, okay, these properties come in super handy. So what if these quadrilaterals were plotted on a coordinate grid then? Well, then we will need to utilize some, we need to understand some basic coordinate geometry in order to show these different properties. So let's take a look at the first one here. And I again encourage you to pause the video and take a close look at this, because again we will be utilizing this in various coordinate geometry proofs. So let's take a look. The first property here, which was opposite sides are parallel, and how can we show this on a coordinate plane? Well, in a coordinate proof, okay, on a coordinate plane, you would utilize the slope formula to show that opposite sides have the same slope. How would you show opposite sides are congruent on a coordinate plane? Well, in this case, then you would use the distance formula to show that opposite sides have the same length. So I say the distance formula because we all know that we don't have to use the distance formula in verbatim. All the distance formula is just the Pythagorean theorem. So you may use the Pythagorean theorem to show that opposite sides have the same length. Moving on here, diagonals bisect each other. How do you show that diagonals bisect one another? One way to show this, okay, is you can certainly show that the diagonals, that one half of the diagonal will have the same length as the other half, but that is much too complicated. If two line segments were bisecting one another, that would imply that the 2 line segments would share a common midpoint. Let's just think about that. If 2 line segments have the same exact midpoint, that means the 2 line segments are in fact intersecting and bisecting one another. So hence, the use of the midpoint formula is actually more appropriate to show that the diagonals are bisecting one another. So we would use the midpoint formula to show that the diagonals share the same midpoint. One pair of opposite sides are parallel and congruent. Well, in this case here, we would use the distance formula and the slope formula to one pair of opposite sides and show that they have the same distance and the same slope. The last property, opposite angles are congruent. Here in this case with the coordinate proofs, you will never be asked to show that opposite angles are congruent. It can be done, however, it will require you to use some trigonometry, which this course does not go into a lot of detail. Quite frankly, some of my calculus students that I've had in the past would have some difficulty finding what the opposite angle measures are for a quadrilateral that's plotted on a coordinate grid. So we will not ask you to replicate this. So you will not be asked to demonstrate that opposite angles are congruent on a coordinate grid. Here are the 5 properties once again. Okay, so let's take a look. So show MATH is a parallelogram. So I have point M, point A, point T, point H have the following coordinates. Please have graph paper and pencil ready. I want you to plot this on a coordinate grid, and I want you to show that this is in fact a parallelogram. Now it doesn't say like what method to utilize, because we have actually 4 different methods to show whether or not a quadrilateral is a parallelogram or not, right? But we're going to go through this in 4 different, using all 4 different ways: opposite sides parallel, opposite sides congruent, diagonals bisect, or one pair of sides are parallel and congruent. We're going to go through all 4 of them with the same quadrilateral. All right, so we're going to show that opposite sides are parallel. How are we going to do this? What was the slope formula again? Because we need to use a slope formula, right? Pause the video, see if you can figure this out on your own. The slope formula, one more time, is equal to this. M is equal to change in y over change in x, which is also the same thing as y2 minus y1 over x2 minus x1. See if you can pause the video and figure this out on your own. And welcome back. So the slope of MA, okay, we can see that change in y over change in x is going to be 4 over 1, or 4. Slope of AT will be negative half. Slope of TH will be positive 4. And slope of HM will be negative half. So on a coordinate proof, it is important, okay, that because this is after all a proof, that you should write a statement to declare that MATH is in fact a parallelogram. And why? Well, it's a parallelogram because since the slope of MA and TH are the same and the slope of AT and MH are the same, then MA is parallel to TH and AT is parallel to MH. Math is a parallelogram. You do need to write a declaration here because, after all, this is a proof. We are showing why MATH is a parallelogram. So, again, let's show that MATH is a parallelogram by showing opposite sides are congruent. I'm going to ask you to pause the video again to demonstrate why this is a parallelogram through this property that opposite sides are congruent. And then at the end, please write a declaration statement that this is in fact a parallelogram because opposite sides are congruent. Go ahead. Hopefully you had some time to think about this, so let's go through it. So we're going to find the distance of MA. Again, you do not necessarily have to use a distance formula. You can simply just use the Pythagorean theorem. And it can be shown that the length of MA is square root of 17. The length of AT can be shown will have a length of square root of 5. The length of TH will again have square root of 17, and the length of MH is square root of 5. So what is the declaration that you should write? It should look and sound something like something like this. Since the length of MA and TH are the same, and the length of AT and MH are the same, then MATH is a parallelogram because opposite sides are congruent. Let's show MATH is a parallelogram by showing diagonals bisect each other. Please pause the video again, take a moment and figure this out for your own, and at the end, please write a declaration for why MATH, again, is a parallelogram based upon the work that you've done. And welcome back. So we're going to show that MATH is a parallelogram because the diagonals bisect one another. So to do this, we will need to find that the diagonals have the same midpoint. So we're going to find the midpoint of AH and the midpoint of MT. So the midpoint of AH can be found by using the midpoint formula, which is just the average of the x and average of the y coordinates. So as it turns out, the midpoint turns out to be 5 halves, 7 halves for AH. We're going to do this again to find the midpoint of AT, and if it all works out, they should have the same midpoint. And as it turns out, it actually does. So what's the declaration statement that you should write then? Since diagonal AH and MT share the same midpoint, then quadrilateral MATH is a parallelogram because diagonals bisect each other. And that's it.